So today we are going to start our triangle congruency proofs. Don't mind my voice, I'm a little raspy from this all week. To start, what we want to do is look over the definitions of the main words we're going to use. Hopefully your vocab quiz that you just took went well. When we're writing down givens, you must write down what it does in a specific diagram. So I'm going to highlight that or underline that on the screen right now. So that's like what we did with our first activity. And that's going to be really, really important that you understand that. So the homework that you did that was due Friday is what I'm talking about there. Then we mark the diagram. Once we're doing that, we can determine if the triangles are congruent. So now let's take a look at each of these words. So anytime I see a midpoint, I look for, sorry, I'm doing this with a stylus, two congruent sides. So with two congruent sides, one point is the end point, of what is being cut, and the midpoint is the other end point. So hopefully that makes sense. We'll look at examples and that it should make a little bit more sense. Next thing we're going to look at is a median. Now, while I don't think you're going to see this as often as midpoint, it's still a word you have to know. So again, we look for two congruent sides. For time's sake, I'm literally just going to write C above because it does follow the exact same format. The median is going to have the same effect as a midpoint. It will divide a segment into two congruent segments. Those two congruent segments will be named with one of the endpoints of the segment being cut in half and the midpoint of that segment. And for a bisector, we're going to do two congruent sides. So again, we have our two congruent sides, and I'm also going to write C above because it does the same thing as a midpoint. So we have three different things that will do two congruent sides, and that's going to be really, really important that you can pick those three things out. The next thing that we're going to do is we're going to look at an angle bisector. So with an angle bisector, we look for two congruent angles. Those angles are always at the vertex of the angle being bisected. When we are doing this, it's easiest to label those angles 1 and 2, just so that you don't make a mistake with order, because remember, order matters. Parallel, we look again for two congruent angles. And in some cases, which we'll see in some of the examples on your homework, we will see that they form four congruent angles. So it's two congruent angles. We have our alternate interior, alternate exterior, and corresponding. Perpendicular. Perpendicular, I'm going to star because perpendicular is one of the trickiest words and one of the most common vocab terms that we're going to see in a standardized testing situation like your Regents at the end of the year. So perpendicular, I have a little 2 there because it will do two things always. Now, we don't get two things from it, but it will have two statements that go with it each time. So we look for two right angles always with perpendicular lines. The lines have nothing to do with it. Sorry guys, I just hit the eraser button of the stylus. So two right angles. And then you have to prove those angles are congruent. And then the last word that we're really going to focus on is a perpendicular bisector. And again, for time's sake, see perpendicular, see segment bisector, because they do all the same things. So this is our fourth one that makes two congruent segments. Now, we talked about these on Friday. Whenever we're doing proofs, just like when we're trying to figure out methods, with a proof, we also still have to look for these bonus pieces. So I'm going to look for two different bonus pieces. One is the reflexive property. And again, this is when triangles overlap. And the piece itself is the overlap. Now, we could see this in questions as a side, and later on, as you guys become more comfortable, we'll also see it with angles. The next one we're going to do are vertical angles, and this is when we have that bow tie shape. And again, the bow tie shape does not have to be a perfect looking bow tie, but we don't want Dracula's bow tie either. So it's a bow tie shape, and the angles are at the knot of the bow tie. So those are all the vocab terms that we have to know. Now what we're going to do is we're going to take a look at little mini proofs. So they're not full proofs, and I don't expect us to write full statement reasons because there's not a lot of room with them. But we will write out everything we need. So we have, why are the triangles congruent? Mark the diagrams and list reasons. Marking the diagrams is going to be really, really essential to your understanding. So for the first one, AB is congruent to CD. Those are congruent pieces, so I'm going to mark them up. Then AD is congruent to BC or CB. Those are congruent pieces, so I'm going to mark them up. Then I need one more thing. So as we look at this, remember, always ask yourself, do the triangles overlap or is there a bow tie shape? So in this picture, the triangles overlap. And where they overlap is DB. So the next thing I'm going to write down is DB is congruent to DB. And then I'm going to write reflexive property, because that's the reason why DB is congruent to DB. Now, we always need to ask ourselves, once we've labeled a diagram, do I have three pieces for each triangle? And the answer to this question is yes. So I'm going to label each piece that's marked, because I know there were some questions about this on Friday. What is marked as side, side, side? And then what we're going to do is we're going to say triangle. And again, we got to be careful. So A, B, D. And what I'm doing is I'm using the letters of what's given to help me figure out the order. Is congruent to triangle CDB. And that's going to be side, side, side. Now, actually, Mrs. Fritz just noticed something, kids. Notice how my B and D's invert? So when I write my reflexive property, I need to invert as well. So it really should say BD is congruent to DB. Sorry, everyone that is using a pen, but that is something that's really important to know. All right, the next one we're going to look at is 2. If I look at 2, I'm given parallel lines. When we label parallel lines, you have to be very careful. We're going to use little inequality symbols. You can put triangles down too if you want. Never mark the segments congruent if they're not listed as congruent. That's so hugely important, and it's a mistake that I see year after year. So that's my given. What I'm going to get from that given, though, are congruent angles. So in a picture like this, we're going to have alternate interior angles. But be very, very careful. I only have one set, and that is wedged between the transversal and those parallel lines. We can do the other set of alternate interior angles only if both sets of lines are parallel. So angle 1 is congruent to angle 2. Oopsies. If two lines are parallel, then alternate interior angles formed are congruent. And then I know AB is congruent to DC. So that is a given. And then lastly, I only have 2 pieces. I need a third, and it's the same picture as number 1, so we know we have an overlap. So this time we'll do it right the first time. DB is congruent to BD, and that's because of the reflexive property. Now I have 3 things in each diagram, so I'm going to label. I'm going to do the bottom one just because there's more room. So DC is a side, angle D is an angle, and DB is a side. So I know my method is going to be side angle side. So triangle ABD is congruent to triangle CDB because side angle side. All right, I think we're going to do one more of these. So let's look at 4. 4 has 2 of my favorite vocab words, perpendicular as well as angle bisector. So for my given, I have RT is perpendicular to AS. So where those 2 lines intersect, I'm going to put a 1, I'm going to put a 2. First thing I got to do is angle 1 and angle 2 are right. And that's because perpendicular lines intersect to form right angles. Next thing I have to do, and this is something every child forgets, is those angles are not congruent yet. I didn't mark them that way on my diagram. So then what I have to do is say they are congruent. So angle 1 is congruent to angle 2. The reason why all right angles are congruent. Notice I'm using some symbols here. It's just because this is a tight sheet on this page. Please do not do them with formal proofs. Now I'm going to mark them. My next given is that AS bisects RST. So at the vertex that's being bisected, which is S, I'm going to put two more numbers down. This time I got to use a 3 and a 4 because I've already used a 1 and a 2. I'm going to mark those congruent. So angle 3 is congruent to angle 4 because a bisector divides an angle into two congruent angles. Now, notice that definition is the same as a segment bisector, but we switch out angle for segment. Please be careful with that. That's a common mistake as well. And lastly, I need my third piece, and we got an overlap. So AS is congruent to AS, and that's reflexive property. Notice how this is getting a little sloppy. We don't necessarily know what goes with what. When we do formal proofs, we have to label each step so we know what's going with what. I've had children in the past not do this. Please do not fight it. So if I label, I got an angle, a side, and an angle. And I then know triangle ASR is congruent to triangle AST by angle, side, angle. So now I think we're ready to start to look at our first formal proof. Crazy, I know. Okay, I have now magically, without you noticing, flipped to the next page because I had to change locations of recording. So, these are my patented, not really though, proof methods. If you follow these methods, proofs will make sense. If you don't, you will be confused. So, I know it looks like a lot, not as scary as it seems. When we're doing a proof, we're always going to start off by creating a T-chart, labeling the left side statements and the right side reasons. So for this first proof, let's actually do that. So I'm going to write statements, and then reasons. Now that we have that done, let's scroll back up. The next step is to read the given information carefully. These will contain the majority of information you need. So what I mean by read those carefully is now explained in step 3. We're going to write each given one at a time unless something repeats. So maybe I have two parallel or two perpendicular. I can put those together. Do not write them all at once. Other teachers will do it that way. I do not for a very, very, very specific reason. Now, after we write them down one at a time, each time you write one down, you need to look at it and say, did that give me two congruent pieces? And what I mean by that, it should say angle A is congruent to angle B. If it doesn't say angle A is congruent to angle B, then it's a no. And if it doesn't say CD is congruent to BC, then it's a no. If it doesn't give me that, then I need to describe what that given is doing in the specific diagram and write its definition as the reason. After I do that and get congruent pieces, I'm going to label each piece on the diagram. Do not do it before you write it down because you guys will forget to write it down. If there aren't three pieces in each triangle, then I have to make sure I look for either a bow tie or an overlap. And then we will prove triangles are congruent. If you notice in step 6, there's a blank and a blank in step 7. Those will not be filled in until later because we're not learning those yet. So that'll be after I'm back in school, thank goodness. Okay, so we're going to take a look at this proof. I got to fix that T because it's annoying the crud out of me. I'm going to start with my first given. Given number 1 is M is the midpoint of LS. And its reason is given. So let's talk about those reasons. Reasons will have 4 categories only: givens, definitions, properties, and your methods. So 4 reasons only for right now. We will add in a few more later. So M is the midpoint of LS. My question to you is, does that give me 2 congruent pieces? Hopefully, someone in the room has said no, and hopefully it's more than one person that has said no. No, because it doesn't say something is congruent to something else. So then I have to think, what is the definition of a midpoint? Let's start with that reason. The definition of a midpoint is a midpoint divides a segment into 2 congruent segments. So now I have to look, well, which segments are going to be congruent? Well, it's chopping LS. Oops, sorry, kids. So there's my M. So what I said on the first page is we're going to use that midpoint and each of the 2 endpoints. I have an L and an endpoint of an S. So it's ML is congruent to MS. Now, eventually you may be able to start with that and then do the definition. It's up to you. So that given has been used. I'm going to check it off. My next given is PM is congruent to QM. Its reason is a given. That's why I know it's congruent. Those 2 pieces are, in fact, pieces. So I mark them. And I forgot to mark my first one. And then I move on. All my givens have been used. So, do I have a bow tie or do I have an overlap? The correct answer is a bow tie. So, I'm going to mark those angles. I'm going to put a 1, I'm going to put a 2, and I'm going to say angle 1 is congruent to angle 2 because vertical angles are congruent. My pen's getting a little funky here, kids. So there's some extra loops when there shouldn't be, like on angles. Sorry. And R. Do I have 3 things on my diagram? The correct answer is yes. So let's look at triangle LMP. LM is a side, 1, an angle, PM, side. So step 5, my prove triangle LMP is congruent to triangle SMQ by side angle side. Now, we're going to write congruent to side angle side. We have to show both triangles have it. I'm going to show you another little trick. Some students benefit from off to the side writing what each piece is. So 2 is a side, 3 is a side, 4 is an angle. Problem with that is, if you don't go in the order of which it should be on the diagram, then it's not going to give you an order, but it'll at least give you possibilities. And we know we can't have tushy, so the only option would be side angle side. So, children, that is our first proof. We're going to look at one more, and then Mrs. Fritz is done, and she is recording this bright and early on a Saturday morning for all you lovely children. Hope you appreciate it. Next page. So, we have SA is the bisector of RT. So, statements, reasons. 1. SA is the bisector of RT. That's a given. That does not give me two congruent pieces, so I cannot move on from it. What's a bisector do? Well, a bisector, which is going to be my statement 2, or reason 2, sorry, divides in this case, a segment into two congruent segments. Yes, I know said not to use symbols, but I'm sure we're running low on time. So now the two congruent segments, SA is the bisector of RT. So SA hits RT at A. So that's my midpoint, and then I use one endpoint and the midpoint, the other endpoint and the midpoint. So RA is congruent to TA. My next given, RS, is congruent to TS. And again, it's a given. That is congruent pieces. So I mark a double line and move on. I've used both of my givens. So now I only have two things on each diagram. Do I have an overlap or a bow tie? The correct answer is overlap. So AS is congruent to AF, and the reason why, reflexive property. And I always tell kids to think of reflexive as the word reflection, because you see your reflection in the mirror. So AS is looking at its reflection, and the congruent sign is the mirror. Now I have a side, and a side. So triangle RSA is congruent to triangle TSA, and the reason why is side, side, side is congruent to side, side, side. Hopefully these two proofs made sense. If not, please make sure you rewatch this video as you do your homework so that you're not struggling too badly. I may be back for IA on Tuesday. So please, please, please make sure you're trying. Until the next video.